Hello, welcome back to Algebra 1, Unit 3 or module online. It's called Module 2B. So thank you, welcome back, lesson 3.3. So this is page 3 in the module. And in this unit or module, we've been talking about a system of linear equations. So if I asked you to solve the equations, what is it exactly that I'm asking you to solve? Well, since this isn't representing real world data, this is just, a system of equations. How to solve this is to find the place where they intersect. Well, how can I figure that out? There's a few ways actually to figure that out. And the easiest way, or one of the easiest ways, the way we're going to go over now is to graph those equations. So if I were to graph these equations, for me, I would want to go ahead and put them in solve for y. So y equals mx plus b or slope intercept format. So let me go ahead and look at these two equations. X plus y equals 6. So if I'm solving for y, I want to get y by itself. So I want to undo anything that's happening to y. What's happening to y? Well, x is being added to it. So this is a positive x. So I need to subtract x from both sides in order to undo that. So y equals 6 minus x. All right, so that is equation 1. Equation 2 is negative 3x plus y equals 2. Again, I want to get y by itself. What's happening to y? Well, I have this negative 3x that's being added to it. So I need to undo this by adding 3x to both sides. So y equals 2 plus 3x. So these are my two equations that I want to graph. Now, these will be easy enough to graph because I know that b is my constant, right? And my slope is b equals 6, and my slope is going to equal negative 1 over 1 because it's the coefficient before the variable, right? So here, what is my constant? It's 2. And what is my slope? It's a positive 3 over 1. All right, so I actually have for us the graph of each one here. So this is the graph of what I have in purple, 3x plus y equals 2, the second equation. And the blue one is the graph of x plus y equals 6. Now, where do these lines intersect? They intersect right here at this point. Well, remember the point has an ordered pair, which is this is going to be 1, right? So our x value is the horizontal movement from the point of origin. That's a positive 1. And the y value, the second number, is going to be our vertical movement from the point of origin, which is a positive 5. So this is 0.15 is my answer. So you can either write that as 1, 5, or you could write x equals 1 and y equals 5. And that's the solution. Now, it's always good to check your work. Remember when you, forever in math, that's what we've been telling you. Check your work, check your work, check your work. So how do you check this information? Well, you stick in your value for x into the equation and y into the equation, use your substitution, and see if you're going to actually get the same answers. So if we plug 1, 5 into this and see if they're true statements, 1 plus 5 equals 6, negative 3 times 1 plus 5 equals 2. Let's see if these are true statements. 1 plus 5 is 6. That is definitely true. Negative 3 times 1 is negative 3 plus 5 is a positive 2. Negative 3 plus 5 is 2. 2 equals 2. That one is also true. So we do have the correct answers. That's how we check our answer in when we are checking to see if we got the correct answer when we're solving for a system of linear equations. Now, there's 3 different types of answers that you could have when it comes to the interaction of some lines. So what we just found is right here, one solution. It's where the lines intersect. And this is an independent type of answer, and it is part of a consistent graph, okay? The other types of solutions you can have are going to be if you had an inconsistent or no solution. So if the lines are parallel to each other, parallel means that they're exactly the same slope and they never ever intersect, right? So parallel lines. Here we have dependent lines. Now, dependent lines are lines that actually sit one right on top of each other. So instead of only having one point in common, every single point is in common in that line. And so therefore it has infinite solutions. So our three possible types of answers are no solution, one solution, which is something like we have here, 1, 5, and infinite solutions. No solutions are inconsistent, and one solution or infinite solutions are consistent. The terminology is not as important as remembering that you can have three types of answers: no solution, one solution, or infinite solutions. All right, so I want you to go ahead and pause this video and try this one on your own. See if you can solve this system of linear equations on your own through graphing. Welcome back. So we already have this one in y equals format. So let's get this second equation in y equals format. 3x minus y equals 7. So I have y here. I want to get it by itself. So what's happening right here? I'm having this 3x kind of added on to the y. So it's a plus 3x up here. So in order to undo it, I have to subtract 3x from both sides. So I'm going to get negative y equals 7 minus 3x. Is y by itself? No, technically it's not. It's being multiplied by a negative 1, isn't it? So we need to multiply both sides by negative 1. So y equals, if I have all of this being multiplied by a negative 1, I need to then distribute it to everything within the parentheses. So negative 1 times 7 is negative 7. Negative 1 times negative 3x is positive 3x. So you can see if I change the sign, I have to change it on each part here. Y equals negative 7 plus 3x is my second equation. Y equals negative 7 plus 3x is how I rewrote that second equation there. All right. So now let's look at these graphed. I actually have them here on the graph for us, and it shows us in the graph, if we look, this is point 2, horizontal movement from the point of origin is 2. So the first number in the ordered pair is 2, and then it is down 1 for the vertical movement to get to the point where they intersect. So our answer to this system of linear equations is 2, negative 1, or x equals 2, y equals negative 1. I prefer it to be answered in this method, but you will see it done both ways. All right, so now let's check this to make sure this is correct. So we have a negative 1 equals 2 times 2 minus 5. Let's see if we can get that answer. 4 minus 5, negative 1 equals negative 1. This one checks out. Let's plug it into the original equation, not our one that we changed, but our original equation. We want to use that one when we're checking our answers, because if we made a mistake when we're moving stuff around, we don't want that to be carried over when we're checking the answer. So 3 times the x value is 2, minus the y value, which is negative 1, minus the negative 1. I can't really do that. So what I'm going to change that to is a plus equals 7. So 3 times 2 is 6, plus 1 is 7. So 7 equals 7, and this checks out as well. So this is a correct answer for us. Here we're going to compare those same cell phone data plans that we saw in lesson 3.2. So we've got the digital data plan and we've got the cell town plan. So what we're asked to do here is go ahead and write an equation for each of the cell phone plans. In order to write an equation, we need to kind of know two things. We're going to need to know the rate of change and what is the initial charge. Normally, when you're asked to write an equation, you're given words. It says a cell phone company charges blank amount of dollars, no matter what, as a standard fee. And then it costs this much per gigabyte. Well, let's think about it in those terms. Remember, we already did some subtraction here and figured out that the rate of change or slope in this case was 5, right? And if you want to know how we figured that out, go back and watch the last lesson. But the rate of change was 5. So if that's the case, if my rate of change is 5, I know that it's going to be 5 times the gigabyte. So let's just say, let's call it data, 5D, 5 times data, right? Well, 5 times data plus what is going to give me my cost, right? So in this case, my cost is 20. And my data I used was 1. So 5 times 1 plus what equals 20. If I plug in some information that I have, I can find the information that I'm looking for. Okay, so 5 times 1 is 6. 6 plus what is going to equal my cost of my plan, my $20? Well, I encourage you always to use your calculators, even on simple problems. 20 minus 6 is 14. So the initial cost for this cell phone plan is going to be $14. Even if you use no data whatsoever, it's going to cost you $14. And then it costs you $5 per piece of data. So we'll have the cost of the cell phone plan is $14 plus 5D. That's for digital data. Digital data. Okay. That's answer 1. Now we have cell town, which is what we're going to need. C equals something. That will be our second answer. Let me go ahead and erase this so I have a little room to work. All right, so cell town is, we figured out this rate of change was 2.5, if you remember. Oh, not D, M. So the rate of change or the slope was 2.5. So we know we paid 2.5 per gigabyte per data. Okay, and it's plus something else will give us our cost. So let's plug something in for what we have here. I have this 0.2 gigabytes, okay, and it's going to cost us $35 if we use 2 gigabytes. So let's look at this. 2.5 times 2 plus what is going to give us $35. 2.5 times 2, I'm going to use my calculator. 2.5 times 2 is 5, plus what is going to be $35? Well, I know that if I add 30 in there, right? So no matter what, if I use 0 data, I'm going to have to pay $30, no matter what, right? And then the cost per the data or the rate of the plan is 2.5. So C equals 30 plus 2.5D. C, oh, I already have C written down, equals 30 plus 2.5D. Now, you could change those numbers around. So we have here an example, the answer written for us, y equals 2.5x. You can use whatever variable you want. You don't have to use D. You could also use x. So 2.5x plus 30 is cell town. Here you have the digital data of 5x plus 15. Looks like I did my math a little wrong there. For 20, it should be 15 instead of 14. So there is the correct equations for you. Let's look real quick at where I made my error. Since I already erased my work, I'm going to redo it really quickly for us. If I knew it was 5 times data plus what equals 20. Right? So if I had 1 in here, 5 plus what equals 20? I don't know how I got 14, probably because I didn't use my calculator or I just wrote it down wrong. But 5 plus 15 is 20. So this should say 15 plus 5d is the formula, or 5x plus 15 is the formula. All right, so we took those equations that we just had and we've graphed them here. You have the cell town data plan, cell phone plan in red, and the digital data plan in blue. And so we're going to use this graphing of the information to answer these questions. So initially, at the beginning, if you use less data, which plan is cheaper and how do you know this? Okay, well, digital data is cheaper at the first part of the plan. Digital data. How do I know this? Because it's this lower part, it's lower. This is a higher line. It's since the cost of the plan is our y-axis, this is lower on the vertical axis. This is the numbers of the cost are lower per the digital. So the graph is lower, is a decent enough answer for that. Graphically, which plan has the greatest rate of change? So the highest slope is increasing the fastest. Well, that's also digital data, if you notice. Digital data increases faster than cell town increases. And what part of the equation helps us to determine this? The slope, or the m, helps us to determine which one has the greatest rate of change. And this is, remember, the coefficient of the variable term. What does the point where the lines intersect represent right here? What does that represent? Well, that represents where the cell phone plans change from one being more cost effective than the other. So at this point right here, we know the plans switch. So if you're using less than this amount of data, it makes more sense to use the digital data plan. But if you want to use more than that amount of data, it makes more sense to use the cell town plan. So this is where the place at which they intersect is going to represent where they switch their location. But that also represents where the solution is. If you are given these equations and just asked to find the solution, you would say the solution is at 645. Okay, what is the domain of both functions and y? Remember, we have two things, domain and a range. And we have two types of data, input and output. And those are represented with two variables, x and y, right? And they all line up like this. Domain is the input, which is the x value. Range is the output, which is the y value. This is the independent, this is the dependent, okay? So domain. The domain is going to be, what are our possible x values, all the possible inputs of data we can have? Well, is there a limit to the amount of data a person can use? Well, especially with teenagers, you should know that you can use crazy amounts of data, right? The cell phone company isn't going to limit the amount of data that you can use. Your parents might go in and restrict it because it costs so much when you use so much, but the cell phone company is not going to. The more you use, the better, because then they can charge you more, right? So there's no limit to the amount of data that you can use in an upward pattern with. If you want to use more, you can. Is there a lower limit? Is there a limit to which you cannot use as much, you can't use any less data. Well, you can't use any less data than 0. You cannot use a negative amount of data. You can't use -2, -7, -4.5. You can't use that amount of data. So it's going to be all real positive numbers and 0. Now, how you're going to represent this in set notation is we're going to include the number 0 because that's our lower limit, and it is included because you can use 0 data if you wanted to, okay? Now the upper limit, there was no upper limit. It went on to what? To infinity. Now when you're writing set notation, you cannot include infinity because it keeps going. There's no way to use an infinity. It's just saying that it keeps going. So you're going to use a parentheses. This is called a square bracket, and this is parentheses. So this is a way to write the domain of both functions. They both have the same domain. All right, so I've got 2 more slides here for you to practice. The first is system of equations practice. Figure out if this is a solution to the equations. And remember, that's how you checked your solution in the past when we had to solve the system of equations, and we graphed them and saw where they intersected. How do we check our answer? That's what you're going to do here. Go ahead and pause the video and come on back. All right, so how we checked our solutions is we plugged in our x value and our y value and substituted and saw if it made true statements out of both equations or not. So here I'm going to have -3 equals 4 times 1 plus 3. Let's see if that makes an accurate statement. So I get -3 equals 4 plus 3. Okay, this isn't looking so hot. -3 equals 4 plus 3, 4, 5, 6, 7. That is not a true statement. I don't even need to continue on and check this one. The answer is no, it is not a solution to this system of equations. All right, so let's look at this one. 2 equals 3 times 2 minus 4. 2 equals 3 times 2 is 6 minus 4. 2 equals 2. So far, we're doing well. 2 equals -1/2 times 2 plus 3. 2 equals, what's -1/2 times 2? Use your calculator. -1/2 times 2. Well, there's only one negative there, so I know my answer is going to be a -1/2 of 2 is 1 plus 3. And then 2 equals, what do we do if we have different signs, a negative and a positive? We find the difference. The difference between 3 and 2 is 2. And then my answer is going to use the sign of the greater value. The greater value number here is 3. It's positive, so my answer is positive. So 2 equals 2. That checks out. So this one is yes. All right, system of equations practice. You will need to have a piece of graph paper. If not, you can use your line paper and just draw in the vertical lines to create your own graph paper. Go ahead and graph all 4 of these equations and find the solutions. That means where the lines intersect. Don't forget to check your work to make sure you got the correct answer. When you're done with that, come back and we'll go over the equations. All right, welcome back. We're going to go ahead and graph these. I have some graph paper on the screen here for me, and I'm going to graph this one in purple. So y equals -1, that's supposed to say x, -1x plus 1. So I'm sorry about that if you were not able to graph that. -1x plus 1, I know is going to have a y-intercept of +1 because of this constant right here, the b value. So b is 1, right? And m is -1/1. So that means I'm going to go down 1 and over 1, down 1 and over 1, down 1 and over 1. Okay? So my line is going to look something like that. Let's look at the second equation. Y equals 1/3 x minus 3. I know that b is -3 and m is going to be 1/3. So -3 for b means that my y-intercept is going to cross right here at -3. And I know I've got a positive 1/3 as my slope. And I can also reverse that, go down and to the left because two negatives make a positive. All right, let's see how good I am at connecting these dots. All right, so we can see that they're going to intersect right here at this point, which is 1, 2, 3. 1, 2, so -2, 3, -2. So the solution to this set is 3, -2. All right, so let's move on here. We've got 6 plus y equals -3. I want to rearrange this. So I'm going to get y by itself. Y equals -3 minus 6x. And then this one is going to be y equals 2 minus x. All right, so with this one, I know that b is -3, and my slope is -6/1. And with the red one, I know that my value of my y-intercept is going to be 2, and my slope is going to be -1/1. So I'm going to start by graphing the red line just because that's the color I have in my hand right now. -1/1. So let's see if I can graph this. Oh, not doing so hot. Oh boy. There you go. All right, let's look at the next one. -3 is my y-intercept. Right there. And I'm going to go down 6 and to the right one. 1, 2, 3, 4, 5, 6, and over 1. So I can, since there's really nothing else for me to go down and over 6, I'm going to go up 6 and to the left 1, which is the same thing. 6 over -1. There's only one negative, so it's still a negative. 1, 2, 3, 4, 5, 6, and over 1. 1, 2, 3, 4, 5, 6, and over 1. Wow. All right, let me see if I can get this graphed. All right. Again, on your paper, use a straight edge. That will help you have better looking graphs than me. Now, it looks like they're going to intersect at this point right here, which happens to be -1 is the horizontal value. The 1, 2, 3 is the vertical value. So the solution is -1, 3. All right, so moving on, let's look at 2x plus 3y equals 9. We're going to solve for y here. So I'm going to start by trying to rearrange some of this. -9 minus 2x. So I still don't have y by itself. I have to divide everything by 3. So 3 divided by 3 is going to be 1. -9 divided by 3 is -3. -2 divided by 3 is -2/3. And so I can see that b is -3 and m is -2/3. So let me go ahead and graph that while I have it up. -1, 2, 3 is here. -2/3 down 2 to the right. 1, 2, 3 down 2 to the right. 3, and I can also go up 2 and to the left 3, up 2 and to the left 3. All right, so this is approximately my line. It looks kind of more like a curve, but there you go. All right, so let me get the next one. Y equals negative x minus 2. Okay, so my b equals negative 2 and my m equals negative 1 over 1. So negative 2 right there, negative 1 over 1. So I'm going to go down 1 over 1, 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 etc. I can already see where my lines intersect right here. Okay. And so I know that's 1, 2, 3 horizontally, right? And 1, 2, 3, 4, 5 down vertically, so negative 5. So my answer is 3, negative 5. All right. Next one, y equals x plus 1. Oops, let me erase these. Y equals x plus 1. In this case, my b is 1 and my slope is 1 over 1. So there's 1. We have a graph right here of a line. There we go. Pretty okay job. And then we've got 3x minus 3y equals 3. So let's go ahead and rearrange some of this. Negative 3y equals negative 3 minus 3x. We need to divide everything by negative 3. Y equals negative 3 divided by negative 3 is a positive 1. Negative 3 divided by negative 3 is a positive 1x. So in this case, we have b equals 1 and m equals 1 over 1. If you noticed, y equals 1 plus 1x is the exact same equation as this, just written a little differently. If we were to rearrange this and put the variable in variable term first and the constant last, put it in standard form, then you would see that this is y equals x plus 1, the exact same equation. And that means it is the exact same line. So what type of solution set do we have here? Well, we're going to have infinite solutions. Every single point is going to be a solution. So there you go, and I hope that you got every single one of those right, and we'll see you in the next lesson.